Hello, ladies and gentlemen. Today we're going to look at parallel lines and proportional parts. We'll start with the triangle's proportionality theorem. It says, if a line is parallel to one side of a triangle and intersects the other two sides, then it divides the sides into segments of proportional lengths. All right. Well, if that's true, then I'm going to start with a triangle. All right, I'll make a small triangle, and I'm going to go ahead and well, let me get my triangle here. It doesn't matter what kind of triangle it is. Let's call it triangle ABC. And I'm going to draw a line parallel to segment BC, intersecting the other two sides. So here's the line. Let's call it line DE. All right. Those are parallel. Line DE is parallel to line segment BC. All right, and this theorem says if that's true, all right, if line DE is parallel to segment BC, then parts AD divided by DC, okay, AD divided by DC will be equal to AE divided by EB. Okay, that's what that theorem says. The converse of that theorem says if a line intersects two sides of a triangle and separates the sides into proportional corresponding segments, then the line is parallel to the third side of the triangle. All right, so I'll draw a triangle for that one as well. All right, and let's just, this time let's do an obtuse, just for fun, okay? All right, doesn't really matter what kind of it is. Let's call that triangle PQR. All right, and I'm going to draw a line parallel to segment QR. All right, there's a line parallel to segment QR. Let's call that line ST, okay? And this theorem says if PS divided by SQ is equal to QR, not QR, excuse me, is equal to PT divided by TR, if that's true, then we know that segment ST, or line ST, excuse me, is parallel to segment QR. That's what that theorem says. Okay, all right, let's go to theorem 7.7. Don't worry about the number. It's called the triangle midsegment theorem. It says, a midsegment of a triangle is parallel to one side of the triangle, and its length is 1/2 the length of that side. So, by the way, a midsegment of a triangle is a segment that connects the midpoints of any two sides. Probably should have defined that to start with, but that's what it is. All right, let's start with a triangle. Just any old kind of triangle would do. Okay, all right. And let's call this triangle LMN. Triangle LMN. And I'm going to measure, if I locate the midpoint of segment LM and segment MN. All right, so let me do that real quick. All right, so I'm going to do, that looks like about 3.6. Half of 3.6 is 3.6 would be 3 points. Let's see, half of 3 is 1.5, and half of 6.3, 1.8. Okay, so right about in here. That point right about here is the midpoint of segment LM. Let's call that point F. Okay, and then I'll locate the midpoint of segment MN. All right, looks like about 3.4, 1.6, so 1.6 would be right in there. So if that point right there, let's call that point G, is the midpoint of segment MN, all right, then if we connect those 2 points, we get a midsegment, okay? All right, so segment FG is a mid-segment because it connects the midpoints of two sides of triangle LMN. Okay, all right. Now, the theorem says that it is parallel, so let's just put this, let's make this statement here. If segment LNF, LF, segment LF is congruent to segment FM, okay, and that means that point F is the midpoint, okay, and segment MG is congruent to segment GN, then line segment FG is parallel to line segment LN, and FG is equal to LN divided by 2, half of it. Okay, all right, let's move on. So, proportional parts of parallel lines, all right? That means I'm going to draw 3 lines that are parallel. Okay, so I'm going to start with a line here. I'm going to come down here and draw another parallel line. And then I'm going to come down further and draw yet another parallel line. Okay. And then I'm going to draw 2 lines that intersect those parallel lines. Okay, let's draw a line here and let's draw a line there. Okay. All right, so I've got line, let's call this line upper line, line AF. The lower line, or middle line, line BE. And the bottom line, line CD. All right, so if I know those are parallel, if 3 or more parallel lines intersect 2 transversals, then they cut off the transversals proportionally. And this theorem really means that if line AF is parallel to line BE, which is also parallel to line CD, all right, then what it means is that AB divided by BC, you need to stay on the same transversal, will be equal to FE divided by ED. Okay. All right. Let's move on to... All right, let's go down to the next corollary, which is the congruent parts of parallel lines. It says, if 3 or more parallel lines cut off congruent segments on one transversal, then they cut off congruent segments on every transversal. Well, I'm going to start by putting 3 parallel lines. All right, let me put one here, and one here, so that those lines are parallel. All right, so those are each parallel. And then I'm going to run some lines across those, some transversals. Let's run one with a negative slope, or one with a positive slope. Okay, and then one with a negative slope. And let's name these points. Let me name these points A of intersection, ABC, G, H, and J. All right, and if I know that the line AG, all right, I'm going to write that down. If line AG is parallel to line BH and parallel to line CJ, oh, and, excuse me, I don't need that comma yet. And I also know that given segment AB is congruent to segment BC, segment AB is congruent to segment BC, then any transversal that crosses or intersects those 3 lines would cut off congruent segments on that transversal, which means that segment GH would be congruent to segment HG. And that's what that theorem tells you. All right, let's go to the next page. On the next page, we're given that segment OI is parallel, segment OE is parallel to segment LN. all right? Find y. Well, that is the parts, parallel parts, and that means that LE, all right, stay on that same transversal, this transversal line LM, LE divided by EM would equal, now go over to the other transversal, and what would correspond with the LE? That would be NO divided by OM. All right, and then I can put in, for LE, I'll put in a Y. For EM, I'll put in the 60. Oops, that's a 0. For NO, I'll put in the 36. And for OM, I'll put in the 48. Now, I immediately see that 36 and 48 are divisible by 12, so I'll divide those by 12 and reduce that ratio, make the numbers easier. 12 goes 3 times into 36 and 4 times into 48, and then I'll multiply y by 4, which is 4y, and that would be equal to 60 times 3, which is 180, so 4y equals 180. And divide both sides by 4, and y would be, let's see, divide by 2 would be 90, half of that would be 45. Okay, so there's your value for y for problem number 1. Let's go to problem number 2. In problem number 2, you were given that segment FT is parallel to segment LA and segment GR. So all 3 of these segments are parallel. And these transversals that intersect those parallel lines will cut off parts, okay? And if I want to find x is the length of segment AT, all right? So I would say, all right, to find x, AT, this part divided by TE, all right, would be equal to, come on the other transversal, LF divided by FE. All right, and you need to be able to do this with the letters as well as just the numbers and variables. So x divided by TE, which is 42, would equal LF, which is 35, divided by FE, which is 21. And I can see that 35 and 21 are both divisible by 7. 7 goes into 35 5 times, and 7 goes into 21 3 times, so that's the same thing as 5/3. And then I would do 3 times x is 1 cross product, and 5 times 42, that's 210, all right? And then I would just divide by 3, and that would mean that x would be equal to 70, all right? So now I know x is 70, okay. All right, I'm next going to find y, and y is the length of segment AR, all right? So I could do, or RA, you can do it either way, it really doesn't matter. RA, and I'm going to stay on that same transversal and go from A up to E, so AE would be equal to, if you come over here, the part that would correspond with RA would be GL divided by LE. That's one way to do this, okay? All right, RA is Y. AE is 70 plus 42. All right, that would be 112. Okay, I do believe. All right, and that would be equal to, GL is 28, and LE would be 35 plus 21, which is 56, all right? And now I see that 26 goes into these two. It goes 1 time here and twice here, and that means I could just think of that as 1/2, and then y would be multiplied by 2, so 2y would be equal to 1 times 112, which is 112, and then if I divide by 2, I would find that y is equal to 56. All right. Now, by the way, you didn't have to use the whole parts here. You could have did this part over that part equals this part over that part. It would have worked for you as well, and you might have been able to deal with smaller numbers, but it works either way. You'll get the same result. You can try it if you need to. All right. Example number 3 says, determine if segment DE is parallel to segment GH given that EH is 3, I'm going to write that on there, and HF is 9, okay, and DG is 1/3 the length of segment GF. Well, what I'm going to do is I'm going to let GF be equal to X, all right? So from G to F is X, all right? And DG is 1/3 of X, or X divided by 3, all right? Or if you want to get rid of the fractions, you could multiply both of those by 3 and let this be X, or Y. Let's just multiply by 3. If we multiply both by 3, all right, this would be equal to X, and that would be equal to 3X. It's going to be the same thing because X is 1/3 of 3X. You do it whichever way you want. I'm going to use X and 3X, all right? And if they are parallel, then if I stay on this transversal, all right, DG, all right, divided by GF would equal, what part corresponds with DG over here? That would be EH. And this is the converse of the theorem that we were talking about a minute ago. EH divided by HF. All right, so if these are true, then we will be able to say that segment DE is parallel to segment GH by the converse of the triangle proportionality theorem. That's what it's called. Okay, so now we'll put in for DG, we know that to be X. All right, for GF, we know that to be 3X, or 3 times that length. All right, for EH, we have 3, and for HF, we have 9. All right, and by the way, this ratio on the right reduces to 1/3. All right, this ratio on the left reduces to 1/3 as well, and that means that, yes, indeed, 1/3 equals 1/3, or if you want to do your cross products, 3 equals 3, and that means that, yes, indeed, we now know that segment DE is parallel to segment GH, and our reasoning would be by the converse of the triangle proportionality theorem. Proportionality, I-T-Y, excuse me, theorem, E-O-R-E-M. Okay, all right, let's turn the page. On the next page, it says, in the figure, RT is 13, XY is 7, segment XY and segment XZ are mid-segments of triangle RST. Find each measure. All right, well, I'm just going to go on and put all the information on the figure to start with. All right, I know that RT, in other words, from here over to here, is 13. Okay, so that's 13. All right, I know that XY, where is XY? Right here, is 7. XY is 7. And I also know that segment XY is a midsegment. Well, if segment XY is a midsegment, point X is the midpoint of segment RS. And if that's true, then that segment right there is congruent to that one. All right. I also know that segment XZ is a midsegment, which means point X and point Z are midpoints. Okay. All right. So that would be congruent to that right there. Segment SX would be congruent, or SZ, excuse me, would be congruent to segment ZT. All right. And now, if this would also be a mid-segment, by the way, all right? So that means, because so this mid-segment, since these two are mid-segments, this segment XY is parallel to this one, okay? It also means that we know this one is parallel to this segment down here, all right? And if this is 7, then each of these halves is equal to 7. So that's 7, and that's 7. And by the way, if you want to find ST, that's 7 plus 7, which is 14. We'll need that maybe. Also, I know that this segment right here is congruent to that segment because of this being a mid-segment. It's half of these two, and that y is a midpoint. All right, so that means each of those are 6.5 because that's half of 13. All right, and then now I think we could probably go over here and find everything we need. All right, XZ is the same as this segment down here, segment RY. It's half of the whole 13, so that would be equal to 6.5. Okay. ST, where is ST? Oh, we found that already. ST was the 7 plus the 7, the 14. All right. And then now we're looking for the measure of angle RYX. Okay. Well, let me highlight that angle, RYX. All right, RYX. Well, that angle will be can be found by using these two parallel lines cut by that transversal right there. And those are alternate interior angles, and the one we're looking for is congruent to that one over there. So this measure is 124 degrees. And that's using the alternate interior angles theorem. All right, if you have any questions, please give me a call, show up in a Google Meet, email me, whatever you need to do. Have a good day. Thank you.